You're lying in bed. Your eyes are closed. Your breathing has slowed. Your muscles are letting go, one by one, the way they do every single night on your way down into sleep. And then, out of nowhere, you're falling. Not dreaming about falling. Feeling it. Your stomach drops, your whole body jolts, and your eyes snap open with your heart slamming against your ribs. You're not falling. You never were. You're just lying in the same bed you were lying in 10 seconds ago. And somehow, this exact experience, this exact sensation, has happened to almost every single person who has ever gone to sleep. Not most people in your family. Not most people in your country. Most people on Earth, across every culture, every era, every language, all report some version of the same strange event. Maybe it happens 2 or 3 times a week. Maybe it's rare enough that you remember specific ones, a particular night, a particular fall, still oddly vivid years later. Either way, you've had this conversation before, the one where you describe the sensation to someone else, and they cut you off halfway through because they already know exactly what you mean. You don't have to explain it. Everyone already gets it. So here's the actual question. Why does an entire species, independently, across thousands of years and thousands of miles and languages that share no common root, keep having the same glitch at the exact same moment every single night? Here's the thing almost nobody tells you when you look this up. You've probably already heard an explanation for this, and it's probably wrong. Not exaggerated. Not oversimplified. Just wrong. In a way that has been repeated so many times online that it now sounds like settled science. We're going to get to what's actually happening in your brain in a moment, because it's stranger and more interesting than the popular version. But first we need to talk about the story everyone tells, because the gap between that story and the actual research says something bigger about how myths get made in the first place. Let's start with what this thing is actually called, because it isn't a dream at all. Sleep scientists call it a hypnic jerk, sometimes a hypnagogic jerk, sometimes just a sleep start. It's classified as a form of wakefulness, which is the medical umbrella term for any sudden, involuntary muscle contraction. Hiccups are technically a form of wakefulness. So is the twitch you might get in your eyelid when you're exhausted. A hypnic jerk is wakefulness's most dramatic performance, a full-body contraction that hits right as you cross the threshold from wakefulness into sleep. Researchers estimate that somewhere between 60 and 70% of people experience these regularly, and that number is almost certainly an undercount, because the jerk frequently happens without ever waking the person up. You sleep right through your own emergency. The ones you remember are just the ones violent enough, or badly timed enough, to drag you back to consciousness. And when it does wake you up, it rarely arrives alone. Most people report the same accompanying sensation. Falling. Not floating, not spinning, not flying. Falling, specifically, often from somewhere high, often ending in a jolt of impact that never actually comes. Some people report a flash image alongside it, a missed step, a curb, a cliff edge, a staircase that wasn't there. The consistency of this is what makes the phenomenon so tempting to explain with a single, tidy story. And a story is exactly what most people have been handed. Here's the version you've probably heard. Millions of years ago, our ancestors slept in trees. To survive the night, they had to stay balanced on branches while unconscious, which is a genuinely difficult problem. As muscles relaxed at the onset of sleep, the story goes, an ancestor could lose their grip and begin to fall. So evolution supposedly built in a safety mechanism, a reflexive full-body jerk that would snap the sleeper's muscles back into a fast, protective contraction right at the moment of relaxation, saving them from tumbling out of the tree. Under this theory, the hypnic jerk you experience tonight is a fossil, a leftover survival reflex, running on autopilot, thousands of generations after the actual danger stopped applying to you. It is, without question, an extremely satisfying explanation. It's vivid, it's evolutionary, it ties your body directly back to a deep ancestral past, and it gives a random, nightly annoyance a heroic origin story. Which is exactly why it spread the way it did, repeated across articles, videos, and casual conversations until it hardened into something that sounds like established fact. But here's what actually happens when you trace this claim back to its source. There isn't one. Sleep researchers who have looked closely at the tree-falling explanation have found that it originates from speculation, not from data. There is no controlled study showing that hypnic jerks correlate with anything resembling arboreal balance loss. No comparative research linking jerk frequency to sleeping posture in a way that would support a falling prevention function, and no experimental evidence that the reflex behaves the way a genuine anti-fall mechanism would need to behave. It is, by the assessment of researchers who study sleep neuroscience directly, a hypothesis that became an internet fact primarily through repetition, not through evidence. Which means that when you hear this explanation confidently stated as science, what you're actually hearing is one person's guess from decades ago, copied forward so many times that nobody thinks to ask where it came from anymore. And it's worth sitting with why that particular guess was the one that stuck out of every possible explanation, because it says something about how myths spread that has nothing to do with sleep at all. The tree falling story works because it hands you a complete narrative in one sentence. A danger, a solution, a hero, you, running on ancient hardware. That's a satisfying shape for an explanation to take. The real answer, a handoff failure between two competing neural networks, is accurate, but it doesn't resolve into a story the same way. It resolves into a mechanism. And mechanisms, it turns out, spread far less easily than stories do, even when the story is the one that's wrong. That gap between what's true and what's tellable is exactly how a decades-old guess about tree-dwelling ancestors ends up sounding more authoritative than the actual neuroscience. So if the tree-falling story isn't it, what is actually happening inside your brain in that split second before the jerk hits? To answer that, you have to understand what falling asleep actually requires your brain to do, because it is a far more violent internal event than it feels like from the outside. Your brain runs on a rough push-and-pull system between two networks. One of them, the reticular activating system, is your wakefulness engine, a cluster of structures that keeps your cortex alert, engaged, and firing. The other, a small cluster called the ventrolateral preoptic nucleus, is essentially your sleep switch, releasing inhibitory neurotransmitters that quiet the arousal system down. Falling asleep isn't a gentle fade between these two systems. It's closer to a handoff, sometimes described by sleep scientists as a genuine flip-flop switch, where one system suppresses the other almost all at once rather than gradually dimming down. Now think about what your motor system is doing during that handoff. Seconds earlier, your muscles were under active, voluntary control, holding your body's posture the way they do all day. As the wakefulness system loses its grip and the sleep system takes over, that active control has to be released, and released quickly. Researchers studying this transition describe it as a brief failure of motor inhibition, a moment where the signals telling your muscles to relax and the signals still trying to keep them engaged briefly cross wires. Some scientists frame it as a kind of neurological stumble, your nervous system's coordination between arousal circuits and calming circuits missing a step during an unusually abrupt handover. The jerk isn't your body reacting to a threat. It's the visible, physical evidence of two competing brain systems fighting for control of your body during the fastest state change your nervous system performs on a daily basis. There's a second theory that some sleep researchers take seriously alongside this one, and it comes from a completely different direction. During REM sleep, your body enters a state of near-total paralysis, called atonia, where inhibitory signals shut down voluntary muscle movement almost entirely. This exists for an obvious reason. It keeps you from physically acting out your dreams. Some researchers have proposed that a hypnic jerk, arriving right at the edge of sleep, might be connected to this same paralysis system essentially running a check, testing whether the shutdown is actually engaging correctly before you drop fully into unconscious sleep. Under this theory, what you're feeling isn't a leftover survival instinct at all. It's your nervous system doing a systems check on a safety mechanism you use every single night without ever knowing it exists. Neither of these explanations requires trees. Neither requires branches, or falling, or ancient predators. What they require is a body managing an enormously complicated internal transition, dozens of neural systems handing control back and forth in under a second, and occasionally fumbling the handoff in a way you happen to notice. And if that handoff is a delicate, precisely timed event, it makes sense that certain things would make it clumsier. This is where the research gets genuinely useful instead of just interesting. Sleep researchers have consistently linked more frequent, more intense hypnic jerks to a handful of everyday factors, stress and anxiety near the top of the list, since a nervous system that's still running hot on arousal chemicals has a rockier time handing control over to the sleep system. Caffeine does the same thing chemically, keeping the wakefulness engine artificially revved up right when it's supposed to be powering down. Sleep deprivation is another major one, and it sounds paradoxical. Being more tired should mean falling asleep more smoothly, but an overtired brain often tips into sleep faster and more abruptly, which makes the handoff rougher rather than gentler. Vigorous exercise too close to bedtime shows the same pattern. Your body's still physiologically primed for activity at the exact moment it's being asked to shut that activity down. None of this is a coincidence, and none of it involves a single tree. It's the same mechanism, a strained transition between two competing systems, just made worse by whatever state you were in 5 minutes before you closed your eyes. But here's where it actually does get genuinely historical, because there's a real, evidence-based ancestral sleep story buried underneath the fake one, and it's more interesting than the myth it replaced. Sleep scientists studying the evolution of human sleep, including researchers who study modern hunter-gatherer groups like the Hadza of Tanzania, have pieced together a picture of how our ancestors' sleeping arrangements actually changed over time. And it turns out that tree sleeping wasn't some brief, distant chapter. Our primate ancestors built nests and slept above the ground for an enormous stretch of evolutionary time, the same way chimpanzees still construct a fresh sleeping platform in the canopy nearly every single night of their lives. At some point, that changed. Somewhere in the deep past, our ancestors moved their sleeping arrangements down to the ground. Researchers studying this shift connect it closely to the control of fire, since a fire large enough to hold back nocturnal predators removes most of the reason to climb for safety in the first place. Ground sleeping also does something else, something that shows up clearly when scientists compare human sleep architecture to that of other primates. Humans get a disproportionately large share of REM sleep, the deep, physically vulnerable stage where your body is the least prepared to react to danger, compared to almost every other primate studied. Researchers studying this pattern argue that this only makes sense once sleeping in a group, on the ground, around a controlled fire, made that kind of deep vulnerability survivable in the first place. You couldn't safely fall into that level of unconsciousness in a tree with no one watching your back. You could once your species figured out fire in a sleeping circle. So the honest version of the story is not that a single reflex saved individual sleepers from falling out of branches one at a time. It's that an entire species restructured where and how deeply it was willing to sleep. And that restructuring happened over hundreds of thousands of years, shaped by fire and by other people, not by a single twitchy muscle reflex passed down like a family heirloom. Which brings us back to you. Tonight, in your bed, there's no tree beneath you. There's no predator circling outside a ring of firelight. There's a mattress, a blanket, maybe a partner or a pet a few feet away, and a nervous system that is still, every single night, performing the same violent internal handoff your ancestors' nervous systems performed long before any of them had a word for sleep. The falling sensation isn't a message from your ancestors. It isn't your body remembering a branch it never actually gripped. It's the felt experience of your own brain switching states as fast as it possibly can, occasionally slipping for a fraction of a second in the process. It happens to you specifically. It happens to almost everyone. And now you know that the moment it happens tonight, it isn't a story about trees at all. It's a story about how strange and how fast the transition into unconsciousness actually is, happening quietly, inside you, every single night of your life. There's something worth noticing in the fact that this took so long to actually explain properly, and that the wrong explanation lasted as long as it did. A sensation this common, this universal, this easy to describe to a total stranger and be instantly understood, and for years the best answer most people had access to was a guess about branches. Maybe that's the real takeaway here, not the mechanism itself, but how much of what feels like settled knowledge about your own body is actually still a story someone told once, that everyone else simply agreed to believe. Tonight, when it happens again, you'll know the difference. Not a fall, not a memory of a fall, just your own mind, doing the fastest and strangest thing it ever does, one more time, the same way it has every night of your life, and the same way it will again tomorrow.